In this video, we're going to have a look at Tutorial 9, question 5.1. So this is a general sort of question that asks you to prove an identity involving combinations, so things of the sort n choose 2. The basic method that we're going to use is we're going to show that the left-hand side, that is this guy over here, is equal to the right-hand side. One useful trick that you often get to use for questions like this is that for any factorial that you have, you can write it as a smaller factorial times by another term. For example, we can write 5 factorial as 4 factorial times 5. And we'll see soon how this is useful. To take a slightly more complicated example, suppose we have 2n minus 1 factorial. Well, we could write it as 2n minus 2 factorial times 2n minus 1. Or we might need to write it as 2n minus 3 factorial, and now we've got to times it by 2n minus 2 times 2n minus 1. So this is just a useful trick that you're going to find you can use quite often in these sorts of questions. So let's get on to our actual problem. So I'm going to work with the left-hand side. And the first thing that I'm going to do is I'm going to move away from using notation like this with the brackets and transform that into notation using factorials. So I've got n choose 2, which is n factorial over 2 factorial n minus 2 factorial. And then I've got n plus 1 choose 2 is n plus 1 factorial over 2 factorial n plus 1 minus 2 factorial. And I'm just going to rewrite that as n factorial 2 factorial n minus 2 factorial plus n plus 1 factorial over 2 factorial, and this is going to be an n minus 1 factorial. In order to do anything with this, I need my two fractions to have the same denominator. So if we have a look at this, we know that using what we had in our useful hint, we know that n minus 1 factorial is really the same as n minus 2 factorial times n minus 1. So I need an n minus 1 in my first term over here. So I'm going to multiply top and bottom by n minus 1. And that's going to give me an n factorial times n minus 1 over 2 factorial, and now I've got an n minus 2 factorial times n minus 1, so that's going to give me an n minus 1 factorial. And then my next term just stays the same, so it's an n plus 1 factorial over 2 factorial n minus 1 factorial. So the next thing that I'm going to do is I'm going to write these as a single fraction. So I've got my n factorial times n minus 1 plus n plus 1 factorial over my common denominator, which is 2n minus 1 factorial. Now in this kind of problem, we know that we want to end up with this whole thing being equal to n squared, so we know that we're going to have to somehow cancel our n minus 1 factorial. So it would be useful if we could rewrite each of the terms in the numerator to have an n minus 1 factorial. So using the same trick that we had before, I'm going to write n factorial as n minus 1 factorial times n, and then I mustn't forget my n minus 1, and then I'm going to write n plus 1 factorial as n minus 1 factorial, and then I need to times it by n, and that gives me an n factorial, and then I need to times it by an n plus 1, and that will give me an n plus 1 factorial. And I divide the whole thing by n minus 1 factorial. So now, if we have a look at our numerator, we can see that we can actually pull out some common terms. So we have an n minus 1 factorial and an n minus 1 factorial. So we could write our numerator as n minus 1 factorial all times the stuff left over. So that's going to be, having a look, those two terms, that gives me an n squared minus n plus, and then the last term over here gives me an n squared plus n. And that's all over our 2 factorial n minus 1 factorial. And now we see the usefulness of having rewritten our numerator, because now we can cancel our n minus 1 factorial in the numerator and the denominator. And if we have a look at our numerator, we've got a minus n, and that cancels with a plus n. And we're left with 2n squared in the numerator and 2 factorial, which is just 2 in the numerator, in the denominator. So those 2's will cancel, and we're left with an n squared, and that was equal to our original right-hand side. There are different ways of doing these problems, so if you have a look at the solutions posted on Vula, you'll see a different solution to this problem. Often you just have to play around and see what you can figure out, and sometimes you'll have to work with both the left and right-hand side, so you might have to do something with the right-hand side. But overall, it turns out to be useful if you can remember this trick that we showed right at the beginning, which is how to rewrite factorials so that they give you something you can work with.